Thanks for that question, Trinity. And yeah, in fact, I'm going to start talking today about some of related things just like that question in the MyLab program. And it is true that once you start a homework assignment, it's not timed. You can do a little bit of work and come back to it later at any point, and you'll still get full credit on there. And it's official. We can now get started. Welcome back, folks. So we're ready to finish off week one. Week one's been really all about just getting started with the course, showing how it's going to work, the Canvas system, and on top of that, the MyLab system through the Axis Pearson. Looks like most of the class is fully registered. If you still haven't gotten registered and there's any kind of roadblock or technical issue that you've encountered, please let me know and I'll do my best to help out. And so for the next thing we're going to take a look into is we did have done a good amount of work in Unit 2A. We're on example 6. But I want to first go back to Pearson, take a look into a couple more tools. There's been some really great questions like what Trinity asked about in the chat. I know the questions last class, say, going in to review and things along those lines. I want to show you how all those kind of things work. But before we get started, taking a look into MyLab once again, any questions, comments, or thoughts to start us out? Okay, well, let's take another look into this system. People have started working, making some really great progress into the homework, so good on you. If you haven't quite had a chance to get into the homework, that's okay as well. And to address again that excellent question in the chat, a nice thing about MyLab and pretty much any good online homework system is you can work these things out piecemeal. You don't necessarily have to clear out an hour of your day to work it in one long stretch. If it makes sense to work the problems for about 10 minutes, 20 minutes, take a break, maybe do a little bit of reading the book, maybe switch subjects to give the brain kind of relax from math, and then go back into it later. That's a great way to do the homework as well. Other people kind of like to just zero in and focus and do it in one long stretch. I think that's how I usually did things in class when I was a student. If that works best for you, then go at it. But everyone learns a little bit differently, and the system isn't going to punish you for that different way you might learn and do homework. But let's go back in here again. This is the button that you would click on to get inside MyLab to open the textbook. And like I slightly complained a lot before, it is a lot of clicking to get started. So let's click Open Pearson. My browser, by the way, if you're curious, does not have cookies enabled. That's a university setting. So that's why I'm always clicking on this. That won't happen on your end. Click on the Open button there. And now we're in the system, but this is the instructor view. So ignore it for just a second until I click on the student view button. We just have to wait for this to load. That's a pretty abnormally long time for loading. I mean, I'm sure it's been like 10 seconds, but that feels like a minute to me already. Sometimes if you hit F5 on the keyboard, it kind of refreshes and tries to reload. No, not this time. It's being stubborn. Hopefully this hasn't happened to you too many times. And it eventually went in. I guess if it looks like it's stuck, walk around, get a glass of water, and then continue, and should come back alive. That was kind of a long wait. That's kind of abnormal for what I've seen so far. And now let me click on Student Home. And there we are. This is about what you'll see when you log in. The textbook is right here, just as a refresh. You'll hit the e-text contents link there. Click on that to open the textbook. But the main thing I want to talk about today again is, if I get back here, Student Home, how the textbook is, or a couple new things about the homework exercises rather. So I have a score of 3.57%. That doesn't look too great, but that's okay. This is still open. I can still come back here and to work on it. I have a due date of January, hang on. I have a date of January 12th, a due date of January 22nd. That means I intend to finish Unit 2A today. If I don't get to it, if there's even one problem left over in Unit 2A, I'm just going to move the due date so it's always exactly 1 week away from when we finish that unit. So just click on this link to go to the homework set. Looks like I made some progress on a couple problems. And really, one really good question that a student asked last class that I wasn't too sure of is, can you go back to this in order to just practice further for, say, an exam setting? And you absolutely can. That would be the review button right here that you would have to hit. So this was 100% completed, but you just wanted to go back in as a refresher, extra practice. Click the review button. It gives you some warnings. Any work you do here will not change your score. So if you're intending to complete the assignment, this is just trying to warn you, don't be in review mode. You're not going to get credit for this work. Click on any question, even a question you worked on or a question you finished. I'll click on that one. Ignore the warning because we know we want to review. And it'll take you back into a homework set involving that question. Let me move that toggle around. But that might not be great because if you've answered that question, this isn't a fun way to review. But you could just click on this button, similar question, and it'll absolutely give you something similar, and this would be the practice problem. We can grab as many similar questions as we would like. It'll change the numbers, maybe the scenario a little bit, maybe not. It's still bananas on either case, but slightly different problem relative to example 5. When you're done reviewing, just get out of this section. Let me see. Let me click on close. That's the button. Then over here, click on back. And now it says changes here will affect your score. This would just be the ordinary completing the homework section. You can click on any one of these problems or click on resume to continue working on that problem. Well, again, thanks for asking for that question about reviewing. I was a little rusty on exactly how that worked. But other questions at the moment? Okay, another question that came up as well over an email was about if you want to redo a problem, how exactly do you do that? I made a statement that you have unlimited attempts on this, but it might not seem that way right out until you really take a look into how that works exactly. So let me go to just a random question, question number 6. Instead of answering the question, let's just imagine that I was really struggling with this one and I just didn't really know the right answer. Let me put 6. And let me put, say, dollars, something that's probably wrong. Once you click on check answer, it'll save that response. It says it's incorrect, and it tries to give you a little bit of advice. Think about what the unknown and the problem is, what the operations can be used to find the answer. Make sure to use the correct units in your calculator. Be sure to round to 2 decimal places. So any one of those things, or maybe all of them, could have gone wrong. It's kind of nice to give some advice, but that advice may not always be fully targeted as well as we'd like. Let's say I'm stubborn and I just tried, well, maybe it's $7. Got it wrong again. They're not very great with the advice. It's the same statement all over again. And let's say maybe I thought it was $87. It says final check, and that might be concerning because I said there's unlimited tries on this. So let's click final check. And it says that's incorrect. I could go to the next question or click on similar question. The similar question is the aspect of it that gives you unlimited tries. Even though if I go on to next question, I didn't get any points on question 6, that's okay. I didn't get any points on question 3 either, but you can go back to any one of those and reclaim your credit. Here's how it works. Go back to question 6. You could have clicked on the button, try a similar problem, and it'd be the same effect. But if you're coming back to the problem that you finished, you want a higher score on, click the similar question down below here. And it gives you slightly different numbers, same context, and we'll just try it all over again. There's no limit to how many times you can do that. So it's like 3 tries on a particular set of numbers that they give you before you get to that final check on the 3rd try. And if we didn't get on that last one, then you can just ask for a similar question and it absolutely will give you one. Any questions about that so far? Okay, so I mean, this is learning. Sometimes you don't always get things right the very exact first time. If you nailed every single question on your very first attempt, maybe you need to be a harder math class. This doesn't seem to be challenging you too much. So it's kind of normal to have to try a couple times over to see how it goes. But if it starts to get really frustrating, if I felt like I spent 20 minutes on this problem and I'm about to throw my keyboard or something like that, I'm just getting really upset with it and I don't see what's going wrong, I might get suspicious that maybe the system is bugged. That's very possible as well. There's other things you can do as well. You could take a picture of that, take a screenshot, ask about it during office hours. During office hours, you could come in through Zoom and just share your screen, and I'll work alongside you to try to see how to make it work. If it's not during office hours time, you can click on this button, get more help. And this is a button that you can use as much as you would like. It's never going to ever over inundate me. I'll be always happy to engage with you every single time you click that button. If it feels like you've clicked that button a lot, maybe you clicked it on every single problem and you're starting to feel kind of bad about that, you shouldn't. I'm extremely happy to engage. I'm an extremely fast typist, and you're never really going to overwhelm me. I say this every semester and it's never ever happened. So if you click on this button, here's what's going to happen. It gives a weird link, and this is from me, so it'll say your name there. You have an opportunity to enter a message, and anything you can say about the problem, maybe the attempts you've tried, or the reason you think that it should have worked but it didn't. Anything you'd like to say at all is just fine. You might even just say, help, this does not make sense. And that's just fine as well. I practically used all caps on that. That's not going to offend me in any kind of way. So you don't have to send a note. Anything you send here is possibly pretty helpful, and I could help you out a little bit better. Click on send. And this is where the MyLab platform, it's not the best in the world. It sends the whole thing to my ISU email address. So I'm going to see the question that you were working on. I'll be able to see the attempts you made, the message that you left with it. But in order to respond to you, I have to look into your ISU email address as well. So I'll look at the problem. I might make a couple screenshots. Then I have to directly email you. So check your Gmail, maybe have it always kind of open, anticipating the response. That's how I'll reply to you. Better homework systems have the reply in the system, but this one doesn't, unfortunately. But that's still a good way to get help. Any questions about the getting more help or other questions so far? Or maybe just other cool things you found so far in here that hasn't been touched on? Okay, we'll use MyLab quite a lot. Again, we also mentioned there'll be weekly quizzes, but we're only going to get started on them on week 2 because we're doing plenty already on week 1, learning the course, learning the Canvas system, learning the MyLab system. I feel like a quiz is just kind of butting into too much already for a week 1. But other things I'd like to point out is you can click on the Help Me Solve This button to get a virtual way of getting through the same kind of problem. You would give you kind of a guided tour on getting through the whole thing. You'll check your answer as you go. And once you do that, it'll give you a brand new problem again over here. So when you click on Help Me Solve This, it really does help a lot more. But then you do have to do it on your own with a fresh, brand new problem. Another thing you can do is just click on View an Example. And, well, click on Continue. And it's kind of like a slideshow discussing how the problem will go, giving you a good idea of how it all should work. Some people respond pretty well to the Help Me Solve, View an Example as kind of like a virtual tutor in a certain kind of sense to help with the problem. Other things you can click on is, again, you could just, if you don't like virtual tutors, just click on that button. This is kind of a nice additional thing. But you know what? I would actually discourage using the built-in scientific calculator. It's kind of a weird typo, only because now you're learning a calculator that you don't have the opportunity to bring with you on an exam. So that makes it kind of a disservice. Instead of using the built-in calculator, in my opinion, it makes way more sense to just use the calculator you'll actually use in a real exam setting so that you're not trying to switch gears suddenly from doing homework one way on a different calculator. And then now you're in an exam setting with a whole new different kind of calculator. That's not a very friendly change in an exam setting. Next couple is you can click on a video. There's video tutorials on how to solve these kind of things. See how that works. I don't think I've clicked on that before. Yeah, it's kind of cool. We won't play that, but you could play that as well. So pretty much what MyLab is trying to do with all these tools here is everyone learns a little bit different. Some people might like to help me solve this, and that just does it for you the entire course. Some people want to talk to a real human, and I'll be happy to help out. And some people respond well to a textbook or a video. If you click on textbook, this is a really cool feature too, because it takes you directly to the right place in the textbook that relates to the question that we're working on at the same time. Well, at least it's supposed to. It took me to, this is the start of the entire section. Well, it could be better. So your mileage might vary on this. It didn't take me to the right parts of Unit 2A. It just took me to the very beginning of it. So I was hoping for a little bit more on that one. We'll never have a reason to use StatCrunch too much, except for the very end of the course. It might come up here and there. But for the moment, it'll be a button that we kind of skip over for now. Well, that's pretty much all the things I wanted to say about MyLab. Any questions or comments so far, folks, before we go back to Canvas? Okay, and you can probably tell why we didn't say all this stuff on day one. That's just too much stuff, too like a million things that we could have talked about in one single day. So we'll occasionally do this. We'll come back to MyLab, maybe to show how to enter in an answer, talk about an additional feature, that kind of thing, as the course goes. So we're not going to just turn it off and never open it again in class ever again. But for the moment, let's close this out and go back to click on Home here in Canvas. And we're going back to Unit 2A. Let me click on, let's get all these back the way they were. So on a typical week, say week 2 and on, what you would see at the very bottom of this particular block, what you'll see on the very bottom of this block right here, is that's where the quiz is going to be posted. I'll probably post it before Thursday because it turns out Thursday is my busiest day. So I might post them a bit early, like on a Wednesday. But they're considered officially signed every Thursday to be due the following Thursday. And I'm glad I scrolled down just as a reminder. On the 19th is Martin Luther King Jr. holiday, so we'll take a kind of a bit of a vacation and come back on Wednesday after today's class. But for now, I think we're ready to turn to unit. I forget these are units, not sections. Unit 2A. Any last questions at all, folks, before we jump back into the work? Okay, so let's get started then. I recall running over about 2 minutes last time that we had class getting through this problem. I'll try to be a little bit better with time management. And it's kind of unfortunate. This is what I would always try not to do. Take a problem like example 6 and split it between 2 days is not the best way to do these examples. So that's going to be my ultimate objective, to try to finish a problem entirely before we call class. But we still have a part C. Let's review what we did so we can actually answer this part C. Example 6 had a weird scenario. Maybe you're an aquarium enthusiast, or maybe this is a swimming pool, but either way, we have 25 cubic feet of water. Imagine you're going to put that in a building. The big issue now is the structural integrity of the building firm enough to hold this weight? We don't want an entire aquarium collapsing down to the next floor. That could be catastrophic. So we have to decide how much does this weigh before we install an aquarium like this. We are given information that 1 cubic feet of water weighs about 62.4 pounds, extremely heavy. The question was broken down, kind of emphasizing the three problem solving strategy. We won't do this on every problem, but here we were just trying to see how does it work exactly. Understanding the problem is really all about know what the context is, maybe imagine a random scenario like I was mentioning with an aquarium, maybe in an office building. Anything you can do to add a little color to it makes that problem kind of stick in your head a little bit better. And the unknown we found was how much does it weigh, it being the water. So we said it's the weight of the water in pounds. Pounds being emphasized as the unit we're trying to come up with when we solve this whole entire problem. So we emphasized the units pretty heavily on this. First, we took the given information, 1 cubic feet is 62.4 pounds, and we got two conversion factors. We took the 25 cubic feet of water, and we noticed because we want pounds, we had to multiply by that factor. In a different problem, it could have been this conversion factor instead. The reason we multiplied by this is units cancel, and all that survives for units is pounds. The cubic feet are gone. We multiplied it straight through the top and got 1,560 pounds. I think all I mentioned is that's a lot of weight. That's getting pretty close to the weight of a very, very small compact car in Europe, for example. Now when it says give a practical interpretation of the result using the context, we can write a statement that goes about along the lines of the weight of the water is 1,560 pounds. Let me try to fix that penmanship there. So when we say using the context, we just have to remind us that pounds is part of the context. We're talking about weight, so we said pounds, and it's the weight of the water. If you left off, say, water here, it wouldn't have been too big of a deal, but we should say something about pounds or water, or possibly both, to really get the context in. So the interpretation is not just 1,560 pounds. We have to say what that relates to, the weight of the water. Really, it's kind of like we're just returning to part A and supplying the number. Well, that's a problem that we ran over last class. I'll return that time balance. We'll probably end a couple minutes early so that we're not spending more time per week. But any questions at all, folks? Getting through this entire problem, top to bottom? Okay, really the rest of the notes and the rest of Unit 2A is problems just about like this. We're going to be working with conversion factors, different units, and I stole this directly out of the textbook. I'm going to see if I can make sure I get a higher quality version of this. This looks a little bit fuzzy as far as the text goes, but this is just a nice quick summary for the different words that come up whenever we're stating a quantity with units, rates, for example. If the word per comes up, we're indicating division, and those are things along the lines of, say, like miles per hour. We could write a statement along the lines of, say, 25 mph to stand for 25 miles per hour. But if we really want to emphasize exactly what's going on with the units, we could also say that that is 25 miles. Recall per indicates division, so we can just write a division symbol to go along with the per. So that's all the p is doing, causing a fraction. And this is per the 1 hour. So that's what per often indicates in a problem. Of often indicates a multiplication. I gave an example of kilowatt hours. These are getting expensive these days. And other things we'll do with units is occasionally square them. I think that's already come up with the cubic feet of water in the last example, or cube them. So if we say we're squaring something, that means there's a power of 2. Like in areas, feet times feet is a fine way to write a unit. But that takes a while to write, so we often abbreviate it as feet power 2, or just say square feet, or even feet squared. I think I usually read it feet squared because I'm looking at this. I see feet, and then I see squared, so I go with that statement usually personally. We're dealing with something raised to the third power. We could either write it in the long form this way. I mean, if you wrote that on an exam, I think that's kind of interesting and fancy in a way. You would never lose credit. It would just be a little bit non-standard. Usually we'll say feet cubed or cubic feet, or write that with the exponent. So this is a nice little just table lookup. So to determine what do we mean by per, what do we often mean by of, and to go along with that problem, there's a couple related computations. Some of these are going to be pretty fast, short and sweet kind of examples. Others are kind of head scratchers or little puzzles that we have to work out and get through. So I have some faster problems and some a little bit more longer drawn out problems to take a look into. This mirrors the homework pretty strongly, but if you see any problem in the homework, doesn't just seem to line up with anything we did here, don't hesitate to ask. I'll be happy to look into that problem. And by the way, this is a pretty good strategy too. When you're doing the homework in MyLab, if you see a problem that seems maybe a little bit strange, you can look into all those tools that we discussed in the MyLab system, looking in the textbook, having the program help you solve it, clicking on the button to email me to ask about it, or you can just go to Canvas, open the notes, and find the related problem that we solved as well. That'd be another great strategy for getting through those problems, particularly the tougher ones. But let's take a look at how this one is going to go. Example 7 says, calculate the cost of 2.5 pounds of apples, 2.5 pounds of apples at $1.89 per pound. That's a pretty fast computation. I think a lot of people, if you saw this in the MyLab homework, you'd think of this as a problem where, let me get that out of there, you just grab a calculator, run the numbers, get a number, and plug it in, move on to the next. We're kind of making a big deal out of every one of these, just for the sake of getting a good feel for how the units go in preparation for when the problems get a little bit harder. And if you're really careful with these, oftentimes you can spot a mistake before you get too far anyways, so this is a pretty good strategy. Because it says calculate the cost, the answer is in dollars. So we'll do the unit analysis, just like on the last example 6, and make sure things actually cancel out the way we expect and get an answer that's actually in dollars. So next thing we'll do is take this thing, $1.89 per pound. Well, the per means this is $1.89. And just like on the quick illustration we did here for 25 miles per hour, this just means per 1 pound of apples. I'll just summarize that as just 1 pound. So if we were to purchase 2.5 pounds, we'll take this number next. I'll abbreviate that unit to LBS for pounds. We'll multiply it by $1.89 per pound. So $1.89 divide by 1 pound. And this is the computation that we'll run through. Now, what's kind of interesting about these problems is there's no guarantee that they gave this in the right order. We wrote $1.89 per pound. It's possible we might have had to flip that fraction to get the right value out. But how do we know for sure that we're on the right track here? The answer is going to be in dollars. Then the dollar sign should be the only unit to survive. That tells us this fraction is in the right order because the pound unit will cancel out. And now it's just a matter of 2.5 times 1.89 with a unit of dollar attached. Again, you might have done that extremely fast. You might have solved the information, and life experiences, numerical literacy just told you, multiply them together and you have your answer in dollars. But the problems get harder, and trying to do it this way kind of gives us a good structure for how to take on the bigger, longer problems, viewing it like this. This is just more practice seeing it through the units. But let's grab that calculator now, take 2.5 times 1.89. We get 4.725. That's a weird number, right? You know, if you had a number like this and you gave it to MyLab, sometimes MyLab will complain about this. They'll say something's not quite right and they'll demand you change it. Anyone see the problem with this answer here?
It needs to be rounded up to the next nearest cent.
Yeah, absolutely. The context here is about money. And so nobody at, say, the Albertsons register is going to charge you $4.72.5. That would be kind of insane. I mean, no one's going to cut a penny in half. They're getting rare these days. So, like you said, we always will round to the nearest cent in the context of money. If this was a quiz or exam problem, I don't think I would take off credit. I'd probably just write a comment. But MyLab is the one that would complain. So it's good to just make that a best practice. So let's take a quick look into rounding like we did last time. We're rounding to this position. Because the third place value is at a 5, we will round up to the next cent, as you said. So this is going to be equal to $4.73. That looks funny to my eyes because 4.725 is not equal to 4.73. So if you want to make that look just a little bit more visually pleasing, you could use that symbol. Now it's just saying approximately equal to. I'm never going to be really too worried about that, too nitpicky. So if you left it as equality, that's going to be just fine. So if you had 2.5 pounds of apples, that's probably a lot. You better eat them fast. You're spending $4.73. Feel like inflation has made that more costly, but we got through the problem. Any questions at all, folks, on the full breakdown of this one? Okay, here's the next challenge problem. Again, these are not too bad so far yet. It says if a person is paid $1,158 and no cents for 40 hours of work, what is the hourly wage? Really pretty similar to the last problem in a certain sense. Well, what's kind of weird about it is if I read through it again, 40 hours of work, of comes up, which indicates multiplication. But this whole thing right here could be turned into just a rate altogether for the hourly wage. We could take just that entire statement and rewrite it as this means the rate of pay is 1158 per each 40 hours. So even though 4 comes up, it doesn't necessarily mean we're going to multiply things in the problem. And that's one thing that, or I guess that was I was thinking of. Just because a word like 4 comes in doesn't mean one of these keywords is missing. We just have to take a look at it and give it a different take. There's a lot of ways to convey the same kind of information. And a different way to convey this is just to say that amount of money per that amount of time. That means we can rewrite this as a division problem and just say we're taking 1158. The per here just indicates that we're going to immediately divide by the 40 hours. And now we're at it. Just do a really fast division. Let's go back into Desmos. 1158 per 40 hours looks like this without the units. Now that's a pretty healthy pay rate. This person is making $28.95 per hour. So we can write this as, let me double check, $28.95 over the 1 hour. That's an okay way to write it. But I think if you wrote it this way, it would look kind of funny to a lot of people. I think a lot of people would prefer to write this as 28.95 per hour. And that's what is meant by the hourly wage. It's per each 1 hour, and that's the amount they get. Well, this is 2 pretty fast problems. I feel like example 7 was a little bit harder because this one is just a really clean division. But example 8 is really just a contrast against example 7, where there's a true unit canceling. Here, we just combine the units together in this kind of way. A little bit different than, say, the mph, miles per hour, because money is special when it comes to units. When it comes to money as a unit, it's always got to go in the front, and that's just the way we work in a human society, it seems like. Well, any questions at all, folks, with those two kind of warm-up problems dealing with units? Okay, let's give another one a try. Try to hide these problems so we're only looking at one at a time, or possibly the last one if you're still copying down. So here's our brand new scenario. It says the basement of a room is 20 feet long, 15 feet wide, 10 feet high. Maybe, I'm not sure where I was going with that statement. I was going to say maybe that's a basement, but I just literally read that it is a basement. So that was maybe a micro sleep just now. So the basement is kind of a nice, maybe a little low ceiling basement, but not too unusual. We want to know the area of this. And then we want to address the question, if it floods, what is the volume of water in the basement? Now, out of nowhere, suddenly we are going to need some formulas for this. One thing I would like to mention is whenever formulas are going to come up, maybe it's a unit conversion factor that you do need to solve the problem. I do print these on the exam itself. So that way, this course is not about memorize a bunch of random facts about different area and volume formulas or different units, like say centimeters to yards, conversion factors. That kind of information will be supplied. The course is more about knowing how to use that information once you have it. So if this was a real exam problem, I will have printed out that area, one thing we want to find is going to be length times width. We also want to find a volume of water. So another formula is that volume is going to be the length times the width times the height of that structure. So those will be supplied on exams. And now, if this was a real exam question, probably the first thing I would want to do before getting started is try to organize that information in a little bit better. It's kind of a geometry problem, really, when you think about it. And a great way to organize the information in a geometry problem is just to draw some kind of sketch. So it's a basement that is 20 feet long, 15 feet wide. I'm going to try to do a three-dimensional looking sketch of this. So this is the length, which is 20 feet. This is the width, which is 15 feet. Not perfectly proportional, but if it's a by hand sketch, it doesn't have to be perfect. Let me try to make that a little bit longer. Then let this be about the same length, going this way. About the same length, there we go. Goes about the same length this way. Maybe there's a little flaw in the basement, but we'll assume that's a straight line. And it's 10 feet high. This is where the extent of my artistic ability is stretched to its limits, really. So it'll look about like that for the basement so far. I've learned that to really get good at these kind of sketches, you have to have a good handle on shading. I do not, so it's really, we're just doing the best we can here. Here's our basement. You would be able to see from the view we see up to that part of the wall, and then this part would be hidden where the dashing line is. Similarly, right over here. You'd be able to see here, and then this would be a dash line. Finally, we could say the height is 10 feet. Not perfectly proportionate on the units we gave, but that's okay. We're just trying to put the information together, have something to look at. You never need to bring out a ruler to try to draw your sketch. So now when it says, what's the floor's area? We're just talking about what is the area of this portion of the basement. All we need to now do is plug in the values. So we'll say that the area is going to be equal to the length times the width. That's the formula cited from above. Now we just plug in the values. The length was given to be 20 feet. The width is given to be 15 feet. Multiply those through. That means grab the calculator as well. We use a calculator quite a lot in this class. 20 times 15 comes out as 300. So we'll get 300, but we'll write this in as feet squared. Whenever we have feet times feet, like on the slide above on the last example, we'll put in an extra power here to convey feet squared in that way. And it might remind you a little bit in algebra, if you take something like x times x, this comes out as an x squared, for example. Same idea with units. They'll obey those same exponent properties. Well, we got it, folks. That's the area of the floor. If they had to say carpet that floor, probably a bad idea if it floods, they'll at least know how much carpeting they're going to need to purchase. Any questions on part A? Okay, so imagining they did purchase 300 feet squared of carpet and the basement does flood, they have a problem. But their biggest problem right away is what to do with the water. For the restoration crew, they're going to probably want to know about how bad it is. You might tell them over the phone, my basement is flooded. It looks like about 3 feet of water down there. Hopefully the power is out. There's no risk of sudden death by going down there. And the restoration crew is probably going to be pretty interested when they hear this and they call in their crew. What is the volume of that water? Because they're going to need to know the size of this job, how much to charge now. Let's calculate that ourselves. We're talking about a volume now, so we'll use the formula. Volume is length times width times height. If we like, we can put in maybe a little bit more in our sketch just to convey there's water here. This is at a height, 3 feet, going from here to here. So now we're ready to plug in the information. The volume, we'll notice it involves length times width. So you could just grab the 300 feet squared if you like and drop it in for both the length and the width. That'd probably be a pretty good strategy. If you can make a substitution like that, it's well worth it. And we'll do quite a lot of substitutions as we go through the course. So think of this as just a practice in this case. Length times width is computed. There's no reason to reinvent the wheel. So we'll just put in that value, 300 feet squared. Then we multiply by the height. What number would you say we have to put in for here next, going in this position for h? Any volunteers for the right quantity right here?
10 feet.
It turns out it would
3
be,
feet.
yeah, exactly, 3 feet on this one. And that's kind of the tricky thing about this problem. It feels straightforward, length, width, height, but something weird happened in this problem. This isn't really the height that we would think about ordinarily, because we want to know the volume of the water. So yeah, good call. We would have to use 3 feet for the actual height of the water we're dealing with. So 3 feet would go here. Then we're all set. We can now say, take 3 times 300. That comes out as a 900. And if we think about this scenario here from algebra, if you take something like x squared times x, the powers add up. This is to a power 1, even though we don't write a 1. And this was a power 1, so it adds up to a 2. Now it's a power 2, a power 1. This will add up to a power of x cubed. And same idea with the unit down over here. If it's feet squared times feet, you'll get a new unit of feet cubed. So we have 900 feet cube of water. If we really wanted to, we could find the weight of that water like we did in a different problem, but that's where this problem ends on this one. Any questions at all, folks, getting through this problem here? Okay, So it's kind of a fun section in a certain sense. We're calculating values that come up in life, like this one, even though it looks like it's a disaster. Again, so far they're not too bad, except example 9 was all about bringing in related formulas to help us solve the problem and thinking about the context as we go. Now, next for the prior example, or the next example, this one feels a little bit more abstract because it's maybe slightly hard to visualize just what's going on in this example 10. It says a pump fills a tank at a rate of 3.5 gallons per minute. We want to know how many hours will it take for this pump to fill a 420-gallon tank. It's going to be hard for me to determine what a real life scenario of this would really be. But if we're thinking of how to solve this problem, let's go to this part right here. How many hours will it take for this pump to fill the gallon tank? This is an important statement to highlight and emphasize because this tells us the answer is in hours. Okay, so we know that much about this. We also have a flow rate or a pump rate. Volume of, I guess this is going to be water, let's assume, is going into this gigantic 420-gallon tank at a rate of 3.5 gallons per minute. So let's put down something for that flow rate. The pump. Forgot how to spell pump. There we go. Pump flow rate is 3.5. I'll abbreviate gallons to just gal for gallons. And let's rewrite this as a fraction so we can do really careful unit analysis. Make sure our answer really ends up in hours. So it's going to be 3.5 gallons per 1 hour. Now we could draw a picture of this if we'd like for the 420-gallon tank.
That's not right. It's
It's per minute. Yeah, thanks for spotting that. Yeah, this would have been way off. Let me fix that there. 3.5 gallons per the 1 minute. Thanks for the sharp eye and quick response on that one. Now we're going to see how to fill a 420-gallon tank using this given information. Again, thanks for spotting that correction there. We're going to get some pretty weird values if we did make that correction. But what's pretty weird is maybe that's what threw me off. We want to answer in hours, but that's not how the information is given. We're given the information per the minute. So we will need a conversion factor on this one as we navigate through the problem. Well, any questions or comments so far? Okay, so let's think about how this is going to work. Our next object is the 420-gallon tank. If you're feeling artistic, you might draw something out like this. I'll show our approach for the folks who feel not as artistic, like me, for example, how you might solve it without a drawing. First thing I'll do is take the volume, 420 gallons. We have a flow rate that we're going to deal with. And so let me know how this feels. Does this make sense? Times 3.5 gallons per 1 minute.
not really. It feels like you need to convert it into how many gallons it would be per hour.
Yeah, absolutely. We need something in hours. But even if we converted this to hours, still looks kind of weird, right? Can you see the second reason this looks just a little bit off?
Aren't we trying to divide it? Like we want to find out how many times it goes into the 420?
Yeah, exactly. If we did this computation, and nobody's going to stop us from grabbing a calculator and going 420 times 3.5 and getting a number, that number has no meaning in this problem because the unit is gallons squared per 1 minute. I don't know what that would mean whatsoever. That's a pretty weird concept, right? So we have to backtrack on this one. And sometimes that's how the math kind of goes before we kind of think about things. But really being careful with the units, like you mentioned, realizing this has to be in hours, and also realizing you can't multiply this, you've got to divide this, as you said, gets us on the right track. So let's try again. Let's put an X here. You know, sometimes knowing what a mistake looks like is important, so let's leave it on paper this way. So second try, take 420 gallons. We can instead divide that by 3.5 gallons per the 1 minute. And you know, it still has that second problem. I still haven't converted this into hours, but really it's kind of up to you. You could convert the rate right here into hours if you like. It's pretty fast. Or you could do the computation here and just convert that result into hours. Either way is a great approach. So I'll leave it up to you to make that assessment. If we went out this way, it's kind of dangerous because we're leaving off the fact that we have hours. So it could be wise to do that first to just get that out of the way. I'll leave it up to the class. What feels like a better approach? Should we go like this? Or should we convert that into hours first before we multiply? Any volunteers for a direction to go? It's kind of a choose our own adventure now.
I feel like it's better to convert it into your hours so you don't, because it'll be a smaller amount to worry about.
Exactly, yeah. And the danger for me personally is if I don't convert it into hours right now, I'm going to get a number and just forget. I'll be happy I found something. It looks right. The unit's correct, except I left that off. So it's probably best to just take care of that right away. Thanks for deciding on the direction to go with this one. Let's make that happen. Oh, hang on, I clicked on something weird. There we go. So next, convert the flow rate to, I'm sensing I need a little more space, so let's just grab a whole new page. Hours, which means we need a good conversion factor. Here's how it might look. If this was a real exam question, I'd probably provide this conversion factor as well, because I mean, it's easy to get stressed out on an exam with lots of random information. And it's really more in particular for the kind of esoteric conversion factor, like we mentioned, maybe centimeters into kilometers would be kind of bizarre. We can write down to just get started that 1 hour equals 60 minutes. But from that, we can do a division. We could say divide 60 minutes into both sides and get the conversion factor of 1 hour divide by 60 minutes. You could maybe have a different version. Maybe you have the minutes and above, hours below. But if we're trying to convert to this right here, hang on, if we're trying to convert this right here, we probably do want minutes in the numerator, right? This is also equal to 60 minutes per the 1 hour. So now we're ready to convert. Let's take that pump flow rate that we found, 3.5 gallons per the 1 minute, and now we can say that rate is just the same as 3.5 gallons per 1 minute. Now multiply by the conversion factor. We're trying to cancel out minutes. We want minutes in the numerator. So we'll use this factor right here, 60 minutes per the 1 hour. Now we have the cancellation we would like. Just like the warm-up problems at the very top of the notes, example 1, we're always allowed to cancel common factors, and we think of the unit itself as a factor. So now, back to the calculator, take 3.5 times 60. We have 210 gallons per, I'll write as a fraction bar, the 1 hour. So it is a 420 gallon tank. You know, you probably already know how many hours it'll take just by thinking about this. It's 210 gallons per 1 hour, and you multiply this by 2/2, that would be 420 gallons per 2 hours. That would actually be a fine way to solve this kind of problem. But if we want to answer that's exactly in just hours, We'll revise that approach and go this way. Let's say, take this, divide it by the flow rate, 210 gallons per the 1 hour. And now it's just converted into kind of a standard fraction arithmetic type problem. This turns into 420 gallons times 1 hour over 210 gallons. The concept that we reviewed that goes along here is if we're dividing by this fraction, we multiply by the reciprocal of that fraction. So now the hours in the numerator, but that's good because it's what we want, hours for the answer. We also have the cancellation we're expecting. Gallons and gallons cancel out. And now we're just taking 210, dividing into 420. That goes in exactly twice. So this tells us it'll take 2 hours. So again, this is possibly a problem you might have just looked at and thought, aside from the conversion factor in the middle, that was the new extra thing to worry about. Once you got here, you might have just visually thought, well, it's got to be 2 hours to make that work. With actual nuts and bolts, canceling the units to make sure we get the right thing, looks like this down below. We did it, folks. Again, these problems can be pretty quick, but pays to take our time with them, in particular for as the problems get a little bit touchier to see what the step-by-step really looks like. Any questions or additional comments on getting through this one? Okay, so that's example 10 down. Here's another example that's similar to what we just took a look at, except this one's all about population. Sometimes these problems are kind of fun to think about, reverse engineer, see what's going on. The last problem had a flow rate. This one has a rate as well. We want to know what is the mortality rate per 100,000 people. So it's really not too different, except the context is quite totally different. In a population of 250 million people, they tell us there's an average of 500,000 deaths per year. I'm honestly not too sure if that's a little or a lot. When it comes to countries and doing comparisons like these, what we like to do is find the mortality rate per some standard amount of people, like 100,000. That way we could compare this country against, say, USA, Canada, and so on, and get a better feel for, is that a little or is that a lot? Well, let's make this one of those problems where let's try this one out on our own. Use the kind of ideas that we've done before, like on this problem above, and I'll let you give it a try. It's a kind of a longer problem. Let's give this one a good 4 minutes. Then we'll all come back together and compare answers, give it a try, compare methods, and so on. Okay, so take out a pencil, piece of paper if you haven't done so already, and I'll get quiet while you give this one a try. Let's go to, say, 7:02. Let's make it 7:03, just to make sure we have enough time to really get through it. So try this on your own, and we'll reconvene at 7:03. Okay, it looks like we're just about there. I put a bit of a hint on what the answer would really look like down below. When they asked for the mortality rate, that means death per year. When it said per, we're dividing 100,000 people, means 100,000 people in the denominator. So our main objective is to get the right number here. And there's a lot of different ways to get at this. Anyone happen to have an answer or a method you'd like to share? Kind of a tougher one, right? One way you could try to think about this one is think going backwards. If they ask for the mortality rate, that's deaths per year. So that's what's going to go up in the numerator. And when it said per 100,000 people, you've got a fraction like this. But then it kind of gives you a bit of a hint. It tells us, well, you have to have people as a unit in the denominator to arrive at this quantity. So we could start by writing out a fraction that goes something people, because we're expecting to get that down in the answer. Then, well, we know a quantity of just straight out people. We have 250 million people in this population. So we can just throw that into this denominator. 250, because it's millions, we'll have 1, 2, 3, 4, 5, 6 zeros altogether. Then the answer is mortality rate per 100,000 people. That means the numerator has to have deaths per year matching that unit we see up here. So we would possibly try putting in deaths. Let me try to spell that right. I think this fraction is going to get a little bit bigger. Deaths per year. And they gave us a figure for the 250 million people of 500,000 deaths per year. So that's a mortality rate. But again, that's really hard to compare a mortality rate like that against other countries that might have wildly different population sizes. So we're trying to standardize it down to a denominator of 100,000 people. And we can do that in stages. Maybe let's just say reduce the fraction. 500,000 will divide into itself once, and it will divide into 250, 1, 2, 3, 4, 5, 6 million, exactly 500 times. So we can next cancel like this. 500,000 goes into itself once, into 250 million, 500 times, and now the whole fraction is one death per year divided by 500 people. So what I've done is taking the original information and just kind of pulled it together to write out a mortality rate. And I think that's the most confusing thing about this problem. It's a complicated unit, right? It's death per year per a number of people at the same time. That makes it kind of tricky to put it together. But now we have an objective. We're trying to get to 100,000 people. So if you can make that denominator be 100,000, you're on your way. How can we do that? Well, it's kind of like getting a least common denominator in a certain way. If you multiply by the right quantity, numerator and denominator, we can force that number in the denominator to be 100,000. So here's the thought that goes along with that. Let's say 500. Multiply that by, let's say, 2, and we get 1,000, but that's not good enough. We want 100,000. Multiply by 20, and we're at 10,000. So multiply it by 200, and we bump up to the 100,000 that we're expecting. So multiply this by 200 over 200, and we get to the target that we wanted to. Looks like in this particular country, and I still don't know if that's good or bad, but we have 200 deaths per year per 100,000. Let me fix that zero there. People. Let me put a box there since this one was meant to be just a hint rather. And that's our official answer right here. That's kind of a tough problem in a way, right? Because again, the unit is pretty random. The numbers are kind of extreme, lots of zeros going on. But does that approach make sense, getting down to that ultimate mortality rate there?
Yeah, I had a question, and
Yeah.
maybe it's just easier to demonstrate it that way. But would it be easier to just divide the 100,000 by 500 to get the denominator?
Let me think of that. Yeah. So if we say divide the 100,000, you're saying divided by the 500,000 here?
Divide it by 500 people.
Oh, divide by 500. Oh, I see what you mean by that 200. Yeah, I think I like that logic a little bit better because this felt kind of like an ad hoc thing that's hard to reverse engineer every single time. Let's put that into the notes. Thanks for that comment there. So to get that 200, let me use this pen right here. We'll take the 100,000. That's the target we were trying to get into. But we had 500 people, so divide by 500. And we know this is right, but to just double check the calculator, seeing is believing, that gives us the factor of 200. And that's what we're using right over here. We multiplied it. Let's put in the color coding to convey that. 200 over 200 to make that work. So yeah, that's a great way to think about it. I think that's a better, more routine way to go. If it was less convenient numbers, this would probably be the required method, really. Other questions at the moment? And thanks again for that comment. I think seeing it that way really helps out on this problem. Sure, you can think about what do I have to multiply and start reverse engineering it, but this is direct. If the numbers were worse, this is very, very convenient to go this way to get that 200 over 200. We did it, folks. I will have to do more research to know if this spells really good for the country's healthcare or it's really bad or what's going on. But we'll end class today here just a little bit early just to kind of balance out the time since we ran over last class. We still have more work to do in this section, so we will finish this when we come back on Wednesday after the Martin Luther King Jr. holiday. Looks like we'll do a little bit more conversion factors. We're going to start mixing units more, find the area, something in square feet, but expressed in yards. The last one, something in a sidewalk. Then also over the weekend, you'll notice there'll be some changes. Things move around in Canvas because we didn't finish Unit 2A. So when we come back on week 2, it's going to be over here. The documents like these, the lecture notes, they end up wherever we finish it. That's where we're going to land. And also before we come to class on Wednesday, you'll see the next sections as well. We'll start getting lined up in that kind of pattern, as well as being posted in my lab through this link here. But we did a lot of pretty hard work. This is kind of intense stuff sometimes. Some people are possibly pretty fluent at it, but doing it from scratch and in particular, showing all these steps is a good amount of work. So we'll take a break a little bit early, but any last questions or comments whatsoever? Okay, well, have a great weekend, folks, and have a great holiday. We'll be back to it on Wednesday's class. If any questions come up, even over the weekend, even over the holiday, don't hesitate to email. I have a habit of checking my emails, usually in the early morning, and I'll get back to you as soon as possible. But take care. I'll see you all on Wednesday.
Thank you.
You bet. Have a good one.